Hi, this is the 10th rule of acquisition redo. This 10th rule of acquisition is something I've been struggling over for a long time because I could never quite get it in a coherent thought. Previously called, instead of higher knowledge is problematic, which just fits it perfectly, that mimic nature before all else. And you're going to see it's the same argument, but this didn't make any sense, really didn't make any sense. So higher knowledge, or knowledge of higher constructs, and we'll define all this in a second, can obscure or misdirect our ability to discern and understand lower knowledge. In other words, meaning more fundamental constructs. And again, we'll define all that. And this occurs because higher knowledge may be incomplete, ambiguous, or just plain wrong. And higher knowledge may look nothing like the fundamental constructs which construct it. And this rule of acquisition is applicable to multiple contexts, and we'll describe those. And the simplest way to describe this rule of acquisition is to dive right in. Let's go back a few hundred years. And let's say that, back a few hundred years, salt was a very important material. Because it's important material, you decide, well, I want to understand more about salt. Maybe if I understand salt and what it's made of. And then you also reason that, well, everything is made of something simpler. So let's say you decide, well, I'm going to try to figure out what salt is made of. And just from the salt crystal sitting right in front of you, really can't tell from this higher construct, how many components make up salt. And what color are they? Well, if you take standard logic, if you mix a red fluid and a blue fluid, you get a purple fluid, which is a darker fluid. So if salt is clear, that means that the components that make up salt have to be clear if you're using conventional wisdom. And what are the properties of the components that make up salt? Well, if you tried to use salt by itself to determine what the components of salt are, you'd fail miserably. So what we've learned over the years is that salt, which is necessary for life, is made up of chlorine gas and sodium metal, both of which are completely toxic to life. Salt is clear, chlorine gas is yellow, sodium metal is opaque and silverish. And so you would get it wrong. There's no property of these items that are in salt. And so trying to go from a higher level construct, knowledge of a higher level construct, which I'm going to call higher knowledge, to understand the lower level constructs which synthesize it, is problematic. You might be able to do it or you might not. This is one clear example where what's happening at the lower level looks nothing like what's going on at the higher level. Let me give you some more examples. But first we need to define some terms to make the discussion easier to follow. So what's a construct? This is what I also call an echelon. A higher construct is something synthesized from a plurality of less complicated or lower constructs. And for example, we have a high-level language, higher life form, molecules, and the salt example is that. Let me give you the high-level language example. Here's the higher construct. Here we have a simple, and I did this on the Arduino. We have a simple thing where we have three integers, a, b, and c, and we're just simply saying that c is equal to a plus b. Now, from our high-level language, this looks very simple, but there's no way to infer from this what's actually going on under the cover. These are the assembly language instructions required to implement c equals a plus b. Okay, there's a plurality of things that have to go. There's 8 instructions that needed to be executed in order to do something as simple as c equals a plus b. There's also higher life forms. Human beings are a higher life form. We're synthesized from plurality of single-celled life forms. And then through evolution, single-celled life forms were the original life forms. And they got together somewhere along the way and said, hey, we need to work together. And they ended up getting together and creating higher life forms. Our higher knowledge is, we're a human being, but that's not enough knowledge of our simple observation of a human being to realize, without instruments, to be able to look down deep and see what humans are made of. Just the higher knowledge we have of each other is not enough to infer that we are made up of single-celled animals. We need instruments to go look and see what we're made of. And then in this case, we have developed the instruments, microscopes, yada, 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 so that we could see. Because from our simple observations, our simple things we're given, we do not have the ability to see that we are made up of single-celled organisms. And let's go back to the epoch of chemistry. This is something I introduced in the earlier videos. This cornucopia shape is something that, way I look at information, way I look at the world. Like for example, we go this way. This echelon or construct is a very simple construct of electrons, protons, neutrons, and forces. These 3 things, or 4 things, or however many forces, synthesize the 100 or so plus elements. Now this green arrow means that these are present at the next echelon. Okay, these 100 or so plus elements, and these are also present at the next echelon, or next higher level construct, synthesize almost infinite number of molecules that you can put these 100 or so elements together to form. Then these kind of break off into other echelons, or epochs, where now these molecules perform DNA. DNA is the synthesizing molecule for single-celled organisms. Single-celled organisms come together to form multi-celled organizations. And those multi-celled creatures can come together to form civilizations, yada, yada, yada. And you have higher constructs as you go this way, lower constructs as you go this way. And this we call higher knowledge, this we call lower knowledge. Now the difference between knowledge and constructs, the constructs are what's real. The knowledge is our attempt to understand those constructs. For example, we know electricity and magnetism exist. Those are a construct. But whether you call it Maxwell's equations or new electromagnetism, those are higher knowledge trying to understand those constructs. So you've got to be careful that because we have a higher construct does not mean our understanding of them is correct. So higher knowledge is the human, higher or lower knowledge is the human perception or modeling representation or abstraction of a higher construct. Lower knowledge is human perception, modeling, representation, or abstraction of a lower or more fundamental construct. Okay? It's important to distinguish. Just because a construct exists does not mean that our knowledge, representation, modeling, or understanding of said construct is correct or complete. For example, the construct of salt has been part of our human culture since the beginning. However, our knowledge of salt has been wrong or incomplete for all but the last few hundred years of our existence. Okay, we need to separate the construct from the knowledge of the construct. Okay, because people have a problem when I say, oh, I think something is wrong. You know, let's say I say, this happens a lot. I could say something like, well, I think our model of salt is wrong. And people go, oh, we don't believe in the existence of salt? And like, no, it has nothing to do with it. It's like salt is there, but our model is wrong. That's what happens when I say Maxwell's equations are wrong. People say, well, you don't believe in radio waves? I'm like, no, it has nothing to do with that. It says our modeling is wrong, not that it doesn't exist or not. And so we get into these arguments because we have melded the two together. We think that our knowledge is complete and therefore a perfect representation of the construct. That is not necessarily true. And that's what gets in our way sometimes. And that's why higher knowledge is problematic. Because trying to discern the lower level constructs from higher knowledge is problematic, since higher knowledge is likely to be wrong and or incomplete. Furthermore, higher constructs may look nothing like the lower constructs you wish to understand. So your knowledge of the higher construct isn't going to help you discern the lower construct. And so we come to the rule of acquisition 10a, avoid deriving down. Just because you have these models at a higher construct, this is your higher knowledge, at an upper echelon or a higher construct, whatever you want to call it, does not mean you can go derive down and discern what the lower echelon looks like, because it may look nothing like it. And because there's probably more going on that's represented here, these are probably incomplete or even ambiguous. Okay, and if you attempt to, now I'm not saying you shouldn't try to derive down, because it might be a case where it works, but you need to be prepared that it's going to be probably a wild goose chase. Now, for example, if I go back to the code example for C++, okay, and I try to discern what C equals A plus B is just from this knowledge, I have no way of knowing that that's what the answer is, because this could be on a different processor. This might be different depending on the optimization level the compiler was set to. There's a lot of information that's not here. Okay, and so the target processor, the level of optimization, and the context what this line of code is in, the type of variables, if these were floating point, that's going to be a completely different set of variables here. And the actual compiler used. We're using, Arduino uses a GNU compiler, but what if you had another compiler? So trying to go from a higher level to a lower level is problematic. However, deriving up is precise, because once you have the lower knowledge here, I can see directly from this code that this is C equals A plus B. All the knowledge is right there. Okay, all I need to know is what these instructions mean, which is basically, you know, but I know what these instructions mean. But that was all you would need to know, and what the instructions do. But from that, you know exactly what's going on here, without ambiguity. And therefore, once we make a guess at what's going on at a lower level, you have to use that knowledge and derive back to ensure that you get what the higher level is telling you. Make sure that they agree. Now let me go, I'm going to just say the same thing, but I'm going to go in a long roundabout way. Okay, salt was probably first synthesized when sodium metal was exposed to chlorine gas. However, early alchemists interpret this and other chemical reactions as a transmutation rather than a synthesis because the products look nothing like the component. So it looked like a transmutation. Looks like you just changed something. And then therefore, because of this magical transmutation, alchemists reasoned, okay, this is the human mind at work here, human mind, that it must be possible to transmute base metals like lead into gold. And the search for material that could transmutate lead into gold was on. And this magic material was called the Philosopher's Stone. Every now and again somebody comes through and says, well, these simplistic understandings are not working. And this person is able to see the correct or more correct mechanism of what's really going on. And in the case of salt, chemistry, it was Dmitri Mendeleev, who discerned the underlying and periodic pattern of the elements. From this more correct lower knowledge, he was able to reconstruct the higher knowledge, the periodic table of the elements, to show that our higher knowledge had gaps in it. And these gaps were later discovered, and these gaps were chemical elements that, according to his lower knowledge, developed. By using his lower knowledge, he developed a table that said this has to be full, and there must be elements in all these empty slots of this new periodic table he developed from the lower knowledge. And those gaps were later filled, and these were gallium, germanium, scandium, technium, helium, argon, thorium, yada yada. And that's why higher knowledge is problematic. And that's the key. When direct observations are not possible, like for example, with life forms, we could use a microscope and see that we're made of single-celled organisms. So we have the machines to do it. But in a lot of cases, we don't have the machines to look down. And so we have to infer from indirect evidence, clues, and develop a theory as to what we think is really going on. Essentially, we're making a guess. Please, let's not elevate it to anything other more than a guess. That's all it is a guess. Let's call it what it is. It arose by any other name. So the rule of acquisition 10b, you have to infer, guess, or computer storm down. Avoid deriving down to the lower echelon. And try not to use prior knowledge, because prior knowledge can block you from guessing or inferring logically. And that's what happened to me when in the foundation series. I tried to use my training, and I thought it should be an inverse square relationship. So what I did is I used a computer to search everything and everything I could possibly fit into the paradigm of the experiment. Things I thought would never, but I would never, the thing that actually came out was something I would have never guessed on my own. Okay, and so instead of brainstorming down, because our brains are limited, computer storm down. Use a computer. Computer doesn't care how many thousands of iterations you want it to. It'll just chomp through it, don't care. It doesn't have a union, at least not yet. So 10b, infer, guess, or computer storm down the echelons. That's the way to go down. And then once you come up with a bunch or many, there could be more than one solution. That's also what we found in the foundation series. You've got to derive up and see which one matches our higher knowledge the best. And sometimes when you do, like which happened in the case of Mendeleev, we might find out that there's more things here that we didn't see or didn't know was part of the set. If you derive up and you agree, that's good. Still, that doesn't prove anything. Remember the first rule of acquisition. Okay, correct answers prove nothing. However, if you get more, if you find out more things, that's a good sign. That's not an irrefutable sign that you've got the right model. That's just a good sign. That just means you have a better model. So when going down, the best thing to do is reduce the ambiguity by going down from as many angles as possible. So from the lower echelon, we're going to pick as many things as we can from the outside. And where they intercept is hopefully the more fundamental model. And hopefully they don't intercross at other areas, which was going to cause us to do more disambiguation. Wrap up. Higher knowledge is problematic. Avoid deriving down. 10b, infer, guess, or computer storm down, preferably computer storm. And 10c, derive up to verify. But remember, just because you verify rule of acquisition 1 does not mean it's 100% true. It's pretty good, probably. If it explains more, that's golden. You're probably better off that you have a good lower model. Okay. Thank you very much. If you could donate, I appreciate it. My website, distinti.com, there's a donate button. My website's woefully out of date. I've got to go find a way to update it or get somebody to update it for me. Thank you.